Hello everyone. Today, in continuation of video lecture series in chemistry, today we discuss about the important concern of the atomic weight and how atomic weight is uh, formed with the various related atomic masses. So there is the difference between the atomic mass and atomic weight. Whatever the concern of the isotopes. So isotopes, we have to see that different mass number, whereas the atomic number is the same. So in case of our earlier video lecture series, in which atomic structures were explained as well as subatomic particles were explained in that particular video lecture series. Today we discuss about the isotopes. So what are the isotopes and how we get the atomic weight of particular elements? Elements, very smallest particle, that is the atom, and various particles of atoms are there, and those atomic particles are the protons, the neutrons, the electrons. Neutrons and protons having the same mass. So whatever their mass is the same, whereas the difference between the electron and these two nucleons, whatever, because neutrons and protons are the nucleon, because they are present in the nucleus. As earlier we discussed about that whatever the comparison between the size of nucleus and the size of whole atom. Whole atom size, that is much more size as compared with the very smallest nucleus. As earlier we have discussed about that, that if we have the whole football ground and one is the football. So football is placed the center of the football ground, and then whole of the football ground is there. So the comparison between the whole atom and nucleus is that nucleus is a football that is present in a center of football ground. Whatever that football ground, and we have already discussed about this, and that is like a planet, solar system. So in which solar system Earth revolve around uh, the sun. So similarly here, continuously electrons moving. There is no definite position of electrons, whatever those are the Millikan concern. So here we say that continuously moving the electrons. Here the nucleus have protons and neutrons. So in case of the nucleus, those are the nucleons. Nucleons means the particles present in the nucleus. And surrounding that are the electrons. But what we have there is the, in case of the different uh, electrons position and where are those, and those are the probable location, whatever those are the orbitals, atomic orbitals in which the electrons are present, and specific atomic orbitals are there for specific electrons. So whatever those are the s atomic orbital, 1s atomic orbital, 2s atomic orbital, that depends on their whatever the shell number or the size. So here the question is there, how we can say that particular atom contains how many number of protons and how many number of neutrons. One thing is there, and this is the well known, whatever the electron and proton having the same, because of their number of protons are equal to the number of electron. So therefore whole atom itself is the chargeless. So therefore number of proton, whatever those are the positively charged particles, and number of electrons, those are the negatively charged particles. So here one more question is there. What do you means by the atomic weight? And one more is the isotopes. Whatever there are also concern of the isobars and isotones. Those are also related with the atom structure. With the nucleons, the variation of the proton number of protons and number of neutrons. So that is here overall what we have. If suppose we have the chlorine atom. So in case of the chlorine, the atomic number 17, and respect to their electronic configuration of chlorine. So 17 are the electron and 17 are the proton, because the positive charge and negative charge are the equal. So here one question arises, why the number of protons are equal to the number of neutrons? Why that particular thing? So that particular is one of the concerned in the same atom, concerned the same atom, and that is the isotopes. So isotopes in which we have the mass number, and then atomic number. So the variation in the mass number, chlorine 35 and chlorine 37, why those appears? And then the atomic weight is 35.453. So why such changes? Similarly, in case of the hydrogen, the atomic weight, the mass, whatever that of hydrogen itself is 1.00797, and that is in the fraction, not a whole number. So this problem, why this problem appears, and what fundamental uh, role of those the nuclei. Nuclei, we have to also say what are the nuclei. Here we can discuss the nuclei, nucleon, nucleus, electrons, the atomic orbital, then the subcell, and then the shell. So whatever the whole atom structure itself, whatever I have already discussed particles of atoms in my earlier video lecture, that is very excellent one. So all of you have to see the video lecture in subatomic particles. So let's we have the isotopes. Isotopes itself is the well known, that is the mass number vary, but the atomic number is the same. And such nuclei with each others are the isotopes concerned of the chlorine, chlorine 35, chlorine 37. So in case of chlorine 35, the mass number is 35, that nuclei, and 37 nuclei, 37 chlorine that have the 37 mass number. But one more thing. What about the protons? Protons are the same in both of the nuclei. So let's we have to see why both have the same number of number of protons. One more thing is that, and that particular concern, that the chemical characteristics, whatever the chemical behavior, we have to come towards the basic chemistry and the definition of elements. So we can say that chemical behavior, what are the chemical properties? Suppose we have the sodium. So the property of sodium that can direct react with the oxygen, because that is the reactive matter. So that is particular property. So why that such properties appears? So that is because of the electrons. So whatever the electrons, electron clearly indicates the changes of the electron. Whatever the bonding is not related with the number of protons and number of neutrons. What we have, the chemical bonding itself either electrovalent or covalent. So that is relates with the electrons. So here The role of proton and neutron is, however, those are much more related with the nuclear reactions, whatever the nuclear explosion, whatever the nuclear bomb that relates with the nuclear energy. Here, in the chemical bonding, whatever the bonding between two or more elements, for example, in case of the water, H2O, so hydrogen and oxygen bond, and then oxygen and hydrogen bond. So that relates with the electron. But when we have to discuss about the nuclear reactions, so what are those particular nuclear reactions in case of the uranium and thorium? So those are, so here that is the nuclei action, and one more is the electron action. So what we have the same chemical behavior in the different isotopes. Whatever the chemical reactivity of two or more isotopes, if they have, is the same, but the mass number varied. And mass number, this is the total of protons and neutrons. So let's we have to come another part of this. So today discuss about the isotopes. Here, I want to go one of the backside of the situation. What we have, what is the materials, and what is the role of material in whole of the universe? Whole of universe. So which material? Air, water, whatever the planet, whatever the different compounds, whatever the laptop, whatever the anything, the plants, the whatever the leaves of plants, whatever the food we are taking. So all those are the material, matter means the material. But chemicals are different because in a material, so many chemicals are involved. For example, plastic. So in case of the plastic, someone polyethylene, that is the polymer, and then some other coloring materials, for example, if chromium compound, so that is the coloring material, the stabilizer of antimony. So then we have some more plasticizers. So that particular plastic itself is the material, but in those particular different chemicals are involved. For example, drinking water. In case of the drinking water, this is the material, this is the substance. But in drinking water, not only the H2O, there are certain water impurities are present. Even whatever the proportionate, for example, different cations, different anions are present. So let's we have the material and then chemicals and then we have the compound. So after compound, we have the whatever the compound itself, the H2, that is the water. But in drinking water, no H2 is there, but along with H2, so many things are there. So that becomes the material. So here, one more the compounds. H2 is the compound, and in which the compound, that compound is formed by different elements. So elements, hydrogen and oxygen. But what about the hydrogen? Hydrogen having the different isotopes, oxygen having the different isotopes. And what are those isotopes? Having the mass number is the same, atomic number differ. So let's we have one by one we can discuss about this. So elements, then we have the particles. The elements, the smallest particle is the atom, but whatever atom is not the smallest particle, atom can be further divided into the subparticles. And what are those particular particles? Are the proton, positively charged particle present in an atom is the proton, and one the negatively charged particles are the electron, whereas the neutrons having no charge, those are the neutral. So here is atoms having the subparticles. Here the proton and neutron are present in a centrally located nucleus, and they also called each other as a nucleons. Nucleons means the particles present in nucleus, whereas in case of, so their nuclear energy is much more greater. So that's why we have to see the atom bomb, the whatever the nuclear reactions, and by which we can get the much large amount of energy for the devastation, for the whatever the sustainable, for the whatever the types of utilization of nuclear energy. Whereas the electron is present surrounding the nucleus, and the role of electron is related with the chemical, with the bonding. So that's we have the electron, proton, neutron, atomic number, whatever the number of proton is equal to the number of electron, and that is the called the atomic number. And therefore then the electronic configuration also vary in the different whatever the different elements, and that was arranged in the modern periodic table. Now, the atomic weight and molecular weight. So, atomic weight itself is of the elements, and molecular weight is of the nucleus of the compound. So, compound, new elements. Okay, compounds, elements having the atoms having the proton, having the neutron, having the electrons, and nuclear energy that is related with the nucleus, and that one is what we have here. The mass number differs and atomic number same, so those are the isotopes. So let's we have to continue. So all of you understand about these things. Now the what we have then isotopes. So this is the very simple definition: the atoms which have same atomic number. Earlier we discussed about the atomic number. So what are the atomic numbers? Atomic numbers are the number of protons, or number of those number of protons are equal to the number of electrons. So now we have to see and the same atomic number. For example, if any of element we are taking and then atoms are there. So in those particular atom, the atomic number is same, whatever the two different atoms of the same element, and but their mass numbers are different. So they also called with each other isotope. One more thing is there. Here the same atomic mass number, but different atomic number. So this is one of the other concept, and much more. Whatever the isotopes and isobars having not much more correlation. Why? Anyone can know about that? Why there is no much correlation between isotopes and isobars? Because isobars, whatever the definition itself, the mass number is same, but atomic number varied. For example, in case of the mass number 40, okay, the calcium and potassium, calcium having the atomic number 20, so 20 plus 20 neutron, so the answer is the 40. But if suppose potassium, the name is the potassium, what are the element having the atomic number 19, and then whole mass number is the 40. So potassium 40, potassium whatever the atomic number is 19, and calcium the atomic number is 20. But if mass number is 20 or 40, 20 of the proton in case of the calcium, and 20 are the neutrons. So 40 mass number, but those are present in calcium and potassium. So that's a very difficult answer. Why? Because the potassium having the different properties as compared with the calcium. So isobars are whatever those means two nuclei having the two different chemical reactions. Why? Potassium having the whatever the reaction of potassium with oxygen, potassium oxide is formed. In case of the calcium, calcium oxide is formed. So their bonding is also different, chemical bonding that relates with the electrons. So as well as the chemical properties, whatever those are also different in isomers. But this is not in the isotopes. The two nuclei having the same atomic number. So that's it. What about that? So that will be clearly indicates that this will there will be uh, the same element, the same element having the but differ in the mass number. Mass number, the number of neutrons vary. So in case of the potassium, whatever that, if we see 39, okay, so 39 mass number in potassium. What is the electronic configuration of potassium? 19 electrons are there. So whereas the protons are also 19. So what happened? If we have to see the number of proton and number of electrons are same in an element, but if suppose there is the variation in the mass number, so that particular variation in mass number, that clearly indicates that there is something complication, and those are they are isotopes. So isotopes are in the same element, whereas isobars in the different element. You have to see potassium and calcium. All of you are well known about that. Potassium is alkali metal, whereas the calcium is alkaline earth metal. So that is the variation. So now we can say why. What we have the clearly indicates that isotopes are in the same element, whereas isotope bars, isobars, the mean is the bar. So bar means the different, whatever the different. So potassium and calcium are different. Their chemical behavior is different, not the same compound form the two elements, because that is the behavior of potassium, and potassium is different. If suppose we have the table salt, so table salt is sodium chloride, whereas how we can say that this can be changed with another nuclei. So definitely if atomic number vary, that is the magnesium. So definitely that will, so here what we have, the potassium and calcium, those can be correlated with the, and whatever those, so here can again the atoms which have the same mass number but different atomic number are called the isobars. Hence isobar have the different atomic number, therefore they have a different number of electrons also, and their chemical properties are also different. So atom which have the same number of neutrons, this is another thing. In this particular case, the number of neutrons are same, but they also they called the each other the isotopes. So there is the isotopes, isobars, and isotopes. So next we can say the chemistry of isotopes. That is the whatever we can say the elemental symbol. For example, in case of the oxygen, there is the chemical symbol. Here we are giving the oxygen itself for the chemical symbol, whatever we have discussed about the chemical properties. So that is the oxygen, and I have earlier discussed about the potassium and calcium. So potassium having the symbol is the K, kalium, and calcium having the Ca. So, but if those are isotopes, so therefore, in case of the chemical symbol of potassium is K and chemical symbol of calcium is Ca. So here the mass number. So mass number in case of the oxygen, the 16, that is the nucleon. So each nucleon, whatever either the proton and neutron, the basic difference between the proton and neutron is the charge, the magnitude, the charge. So here neutron having the no charge, but proton having the plus charge. So therefore mass is equal to number of proton and number of neutron. So this one is the 16, this one is the well-known in case of the oxygen 16. Mass number is the total number of protons and neutrons in an atom. Number of neutrons in the oxygen atom itself is whatever the 16 minus 8, 8 are the proton indicator. So therefore proton, number of protons equal to number of electrons. So atomic number is the number of proton in an atom. Each oxygen atom has the 8 protons. As the number of electron is equal to the number of proton in an atom, and each oxygen atom contains 8 electrons. So this is whatever the simple, whatever the chemical symbol, and there the mass number representation, whatever the upper side, and then below side itself is the atomic number. So this is the clear indication of the chemical symbol of oxygen atom. Similarly, what we have one more thing is there. If suppose they vary in their the mass number, whereas the chemical symbol is the same. Chemical symbol is the O, and here the downward the number of protons are also the same. So what is the variation? So we can see all of you can vary. You can see the picture and where the 16, 17, and 18. So what is the 16 and what is the 17? 16, 17, and 18. So the question is there 16 number, 17 number, 18 number. Those are the mass number. So mass number 18, which will be the heavier. So oxygen 18 will be heavier as well as oxygen 17 will be heavier than all of those of the 16. So here the question is there why that particular mass number vary. So in general, whatever the then we have to back to the Earth origin, and definitely the Earth origin clearly picturized that there are the different mass number of the same element. Why that occur? This is because of the nuclear. So many reactions, how elements are formed. Recently, the number of transuranium elements are prepared, and those are the bombardment of the helium. Whatever those are the bombardment of X-rays by which we can synthesize, we can prepare the transuranium elements. So, like that, here, whatever the reactions, nuclear reactions happens, and in those particular case, the different isotopes are originated. So here, in case of the oxygen 16, one thing, and oxygen 17, another thing, and oxygen 18. So oxygen 18, oxygen 17, oxygen 16. 16 O16 mass number is 16. O17 the mass number is 17. The O18 the mass number is 18. Whereas the atomic number in all those three nuclei species is the same. What is that particular? The atomic number is the 8. So number of proton 8, number of electron 8, because the same positive charge, then we have the same negative charge. And then the chemical reaction, those are related only with the electrons. So whatever, if suppose oxygen want to make the covalent bond, so that is because of the 8 electron, and that is not because of the whatever the 9 of a neutron and whatever the 10 of neutron in case of the oxygen 18 and oxygen 17. So therefore we can this clearly picturize, and this indicates that all these three are isomers with each other. So let's we have to continuation of this. So therefore all of you can understand what are the isotopes. Here the clear indications. What is the n is the in this particular case the number of neutron in case of the 16. So in mass number it's the 16, the proton number is the 8, but variation in number of neutron. So in this particular O168 there is a small n represents the number of neutron. In case of the 17, this is the clear picture where we can see the number of neutrons are 17, are 9, because the mass number is 17. 17 is subtracted by the number of protons, So number of protons are 8, always 8, because the oxygen vary. Then the number of neutron is the 9. In the third case, this third isotopes, here the oxygen is 8. So oxygen itself is 8, and then whatever the mass number is 18. So here we can say, and what about the number of neutron? That will be 18 minus 8, because here you can say the number of electrons are here the same, whatever the same in all three different species. So this one clearly indicates that there are the in nature the any of elements having the different mass number, but the element itself is the only where the proton is the same, because that is the electron is same. So that it will be the character. Now we have the another example so far. Here you can say the carbon isotope. Here the picture is clearly indicate whatever that carbon 12. In case of the carbon 12, 6 are protons, and because the picture is like a smiling one, so what happened in those particular case, carbon 12, carbon 13, and carbon 14. So carbon 14 does not smile. Why? So that is the availability. That is the unstable concern also. So that is also whatever the stability of those. So here you can see another example, and that carbon 12 and carbon 13. So carbon 12 and carbon 13 both are the isotopes, but maybe the carbon 14. In case of the carbon 14, the 6 protons and 8 are the neutron. So there are carbon 12, carbon 13, and carbon 14. So all of you know about the when we can determine the age of our Earth, whatever the age of older monuments, older stones. So that can be measured with the carbon dating, and that can be represented with the carbon 14. So that is the unstable, whatever their half-life period. So here, why in the picture, the carbon 14, the carbon 14, the that this is the unstable. So the picturize, whatever the picturization is there. So here the same are the carbon 12 and carbon 13. So here in case of the carbon 12, 6 are protons and 6 are the neutrons. And whereas in case of the carbon 13, 6 are the protons and 7 are neutrons. So unstable carbon and 14, this having the 6 of proton and 8 of. But what we have, the number of protons are the same. So the behavior of chemical behavior is the same. Whatever the electronic configuration is the same, no variation in the electronic configuration, because number of electrons are changed, and that definitely that is the behavior is also changed totally. So therefore, we can say that this all these three are the isotopes. So that is the very great role of isotopes in deciding the atomic weight, whatever the unstable nuclei is also there. So those are related. So here, do all isotopes of the same elements have the same mass? This is the question. All isotopes of the same element have the same mass? That differ. That will be in case of that. So whatever, if suppose the plus, then we can get in those three cases, whatever in one case, the 6 proton and 6 neutron. But in another case, one electron is added. In the third one, there is the 2 electrons are added. So therefore, 2 isotopes of these are here. That is the relationship, and that is regarding the hydrogen. So we have the so there is the concern of the hydrogen. So next we have to see, and this one of the whatever those anyone, hydrogen, deuterium, and tritium. So in case of the tritium, hydrogen having no H, H having no neutron. In case of the deuterium, mass number is 2. So deuterium, whereas the proton is the 1. So whatever the yellow ball indicates the proton, and whereas the orange ball indicates the neutron. So here hydrogen, deuterium, and the another third one is called the tritium. So hydrogen, deuterium, and tritium, all those three are the isotopes in hydrogen atom. So definitely there the atomic weight relates with the available whatever the available percentage of the deuterium and tritium. Whatever those are the available, whatever the composition in nature. If we have take the hydrogen sample, then we can identify that how much is the deuterium and how much is the uh, how much are nuclei of the tritium, not titanium, tritium, T. So how T and D and H. So they are proportionate, whatever those isotopes are present in a sample of hydrogen. So in a sample of hydrogen, deuterium is present and tritium, but their proportionate are very low. So that's for their the hydrogen having the atomic weight 1.00797, not in the that is in the fraction. So why that particular fraction? Similarly, in case of the chlorine, that is the atomic weight is also in the fraction, that is 35.453, not like a 35. 35 is the mass number. Then why that is in the fraction? The atomic weight of hydrogen is why here in the fraction, that is in 1.00797, whereas in case of the chlorine 35.453. So that's it. Why that? This is because in nature, in whatever the environment, whatever the existence of our earth, so those particular present the number of whatever the nuclei of hydrogen vary, and those the proportionate is also varied. So therefore the atomic weight of hydrogen is 1.00797. So all of you we can understand what is the isotopes and what are the great significance of isotopes in our life as well. Whatever the carbon 14 that is utilized for the purpose of the whatever the life of any of the old materials, and what is the age of that particular, if we have the stone, so we can easily calculate the with the help of carbon 14 the technique, and we can identify that how much old is that particular stone, how much old is that particular, so we can calculate carbon dating. So that is relates with the oxy isotope. So isotopes itself have a great significance, and finding whatever the question, that is the atomic weights are in the fraction. So what we have to concern. So let's we have here the hydrogen, titanium. So now here the clip, this is the clear picture, whatever the isotope chemistry. Here we can say that is the hydrogen atom, whatever the structure. Here only one proton, and here in case of the carbon having the six proton and six are the neutron, and there the electrons are also the six. In case of the hydrogen, the electron is one. So what we have that clearly indicates that in an atom their structure is there, but the nucleons, those are present in the nucleus, and those nucleon number varied, and that is that particular gives us the isotopes, and definitely that will gives us. So here we can get the average weight or whatever the average atomic mass, and this can be obtained because of the isotopes. So here the atomic mass of an element is listed below the symbol of each element on the given the mass on average atom of the element compared to the carbon. So here we have the fixed amount, fixed unit, and that is the carbon 12 is the base. And in case of the carbon 12 nuclei, only six are the protons and six are the neutron, and mass number is 12. And whereas the number of electrons are the six. So by calculating this, we get the atomic mass, whatever the atomic weight, and this we can get 24.31 in case of the magnesium. So that is in the fraction. So why that particular magnesium having the 24.31 instead of whatever we have to see the magnesium having the atomic number is the 12, and when we have the magnesium 24, so magnesium 24 itself is there, the protons are 12 and the neutrons are the 12, but that can vary, and there is the significance of that particular isotope. So isotopes can give the average atomic mass. So here the calculation of mass number because of the isotope. So here very simple concept itself is there. So the calculation for the atomic mass requires the percentage of abundance of each of the isotopes. So atomic mass of each isotope of their element, whatever I have discussed earlier in a great extent. So therefore, the mass of isotope, then the percentage. If suppose we have the chlorine, so chlorine having about 66% is the 35 and 33% is the 37. Then overall we can calculate in case of the chlorine, the answer is the 35.453. So here the mass of the isotope, this multiply with the percentage of abundance of that particular. So let's we have the hydrogen. So in case of the hydrogen, we have to see whatever the abundance of hydrogen, whatever the abundance of deuterium, and then abundance of tritium. So overall average atomic mass will be given, and that is the atomic weight. So let's we have the another concern, and that concern we have to see the different multiple choice questions, whatever that can we have to see our the memory application of so knowledge can be applied on these multiple choice question. Isotopes of an elements have the blank atomic number but mass number. So so what will be the answer? Anyone can give. Here the four options are there. And what are those particular four options? A is the same atomic number, but the same mass number. So this one is incorrect. In case of the B, the different atomic number, not but same. This answer is also wrong. Same. And the option number C is the correct, where the same atomic number but different mass number. So the correct answer in this particular multiple choice question. And we have the another one, whatever the isotopes here that clearly indicates occupy the same place in the periodic table. Here the answer itself is the whatever the isotopes, then isotopes having the chemical properties is the same, similar chemical properties. Here the another multiple choice question, and that is what we have the electronic configuration of isotopes. This one is also the same. I have already discussed in the present video lecture series that we have already discussed about that. The electronic configuration of isotopes of an element is the same. Why? Because the number of proton are the same and number of proton are the same. So therefore, the number of electrons are the same. So this is the answer. Correct answer is the same. Now another one, the mass number is given by here, and the Z is the atomic number and N is the number of neutrons. So the correct answer, mass number here we are taking with the chemical, the symbol A, and Z is the atomic number, or N, capital N is the neutron number. So the correct answer is the B, where A is equal to Z plus n. So therefore, the correct answer, the mass number is equal to the atomic number and plus the number of neutron. Atomic number, we can say the uh, uh, number of protons. So number of proton and neutron both having the mass number. So here we have given atomic number. Atomic number, whatever that, if anywhere we can go, the number of protons with the same, then number of proton are also equal to the number of electrons. So electron, proton, atomic number, whatever, the same thing. Atomic number, proton, and number of protons and number of electrons. So here the confusion. So what about the mass number is equal to atomic number plus whatever that is the number of neutrons. So here an atom of blank contains no neutron. Anyone? That is the hydrogen, because we have already taken the structure, whatever the structure of atom, and hydrogen only one proton and one neutron is there. So let's we have the correct answer. Here the an atom of hydrogen contain no neutrons. An atom of hydrogen contains no neutrons. So that is the correct answer. A. Right? Now we have one more question. An atom undergo bonding in order to attain the stability. That is the question. Whatever the great, any of stability, the compound forms having, that is because of that is the stable. Stable. Anyone want to more stable. So attain the stability, atom undergo the chemical bonding. So why? And that particular bonding, chemical bonding, this one is because of the electron, not because of the proton and not because of the neutron. However, there is the other aspect. What is there? The nuclear energy. That is very strong energy by which the nucleons are present in a very small nucleus. So that is the nuclear energy, and that is the whatever that can be used nuclear energy in constructive wave as well as the destructive wave. Destructive waves, that those are the atom bomb and whatever the man-made disasters, whereas the non-destructive, the application of nuclear energy to generate the electricity, the power itself by the nuclear energy. So here, two atom undergo the bonding in order to attain the stability. But there is no loss of stability. Now, one more question: calculation of mass number, and this is because of the isotope. Whatever is also I have earlier discussed. An atom differs from its ion in which among the following. This one. So that is because of the number of protons. So let's we have there is whatever the calculation of atomic mass of magnesium that I have earlier discussed. In case of this, the average mass was calculated in case of the magnesium, and that is the 24.31. So here you can see whatever the last slide here, the atomic mass unit, that is the weight of whatever the mass of atom mass unit, and in case of the magnesium, so there is the abundance, and these abundance you can certainly calculate, and whatever those can give the answer of the atom. So I think all of you have well known, and I suppose you can understand whatever the great innovations because of the isotopes, and how we can say the isotopes are the concern of the atomic weight, a concern of the mass weight, mass number. So how these certain isotopes are relatively what we have, that particular the nucleons. So nucleons, if suppose we have the helium, so that is the alpha ray, helium having the two proton and four of the, so that is the case. So here the nuclear power. Nuclear power is where situated in the centrally nucleus. So centrally nucleus having the proton and the and the neutron. So, but in isotope of the same element having the different, so that clearly indicates that is the miracle, and that particular whatever the Einstein's whatever the energy is equal to mc square. So this isotopes are one of the most concerned and most concerned in evaluating the energy from the nuclear power. So there is the role of isotopes itself is most important in the calculation of atomic weight. So certainly we have so many answers we get in the chemistry because of the isotopes. So what we have, we can conclude here whatever the how we get the calculation of mass number here, the mass number, the number of electrons, number of protons. So whatever the structure of atom, how many protons are there, how many electrons are there, and how many number of protons are there. So overall, what we have, we can conclude here, and that is the answer. So if anyone want any of the query, so he or she can ask me uh, or give me the WhatsApp. My WhatsApp number and mobile number are there in Suresh Ganviar University website. And if anyone want to contact me with mail, so my email is also given in the Suresh Ganviar University website. And here, whatever the email ID, rc.chipa, chhipa, at the rate of myganmere.com. So anyone want to contact me, then he or she can write me the mail. Okay, and I suppose that this particular today's topic is most relevant for all of us. So thank you for all, and whatever I am happy that you have listened my whole lecture, and I am thankful to all of you. Okay, thank you. Thanks for all.